Hey folks, welcome back to Precalculus. Today we're in Chapter 1, Section 5. We'll be solving quadratic equations. So you can see we're going to start off with a whole slew of vocab and everything. So let's jump right into it. So you can see here an example of quadratic equation, meaning ax squared plus bx plus c is equal to 0. Okay, this means it's going to be a quadratic. Okay, and we'll play with some more quadratic-like equations as we move through the chapter and move through the year. Okay, so anyways, standard form is when the terms of a polynomial are written in descending order of degree, beginning with the highest degree term, and it's set equal to 0. Okay, the leading coefficient is the coefficient of the highest degree term. Okay, and for a quadratic equation, we call that A. You can see that above, up here. Okay, we call that the leading coefficient. B is the coefficient of the first degree term, and C is called a constant. Okay. All quadratic equations are polynomials of degree 2, but can have 1, 2, or 3 terms. Okay, so let's go down here and take a look at some examples here really fast and say, like, okay, we want to figure out whether or not the equation is a quadratic, and if it is, write it in standard form and identify what A, B, and C is. Okay, so is this a quadratic? Yes, it is. Yes, it is. It's a polynomial of degree 2. Okay, we can write it as 3x squared minus 81 is equal to 0, with A being 3, B being 0, there's no B term, and C being negative 81. Okay, what I want you guys to do right now is pause the video and do the next 3 examples on your own. Okay, diving back in a little bit more some vocab here. We'll talk a little bit more about the answers to a quadratic. So solutions, or sometimes called roots, are the values that make the original equation true. Okay, the answers to the equation. Okay, one method to solve a quadratic equation is to first factor, and second, apply what we call the zero product property, which you can see below. Okay, the zero product property basically says that anything times anything, if anything times anything is 0, then one of those things has to be 0. Okay, so you can just set them both equal to 0 and solve. So here we go. If the product of any 2 or more factors is equal to 0, then at least one of those factors must be equal to 0. Okay, so let's dive onto the back here and do a couple examples of using the zero product property. All right, so first we want to write our equation in standard form, our quadratic in standard form. So 6x squared plus 3x is equal to 0. I can factor out a 3x. It's going to leave me with a 2x plus 1 is equal to 0. Now I've factored, and now that I have something times something is equal to 0, I can set each one equal to 0 and solve. Okay, and I get an answer for my left one here. X is either equal to 0. If 3x equals 0, that means x is equal to 0. And if 2x plus 1 is equal to 0, you can do some mental math or you can write it out. X is going to be equal to negative 1/2. Okay, so right now what I want you guys to do is pause the video and see if you can factor this quadratic and find the answers for that using the zero product property. Okay, moving on, let's talk about the square root property of equality, which basically means get something squared on one side and everything else on the other side, and then you can square root to solve it. That's all that means. So we're going to dive straight into an example here and say, okay, we just want to get something squared by itself on the left side and everything else on the right. So I'm going to add 36. So I got 9x squared equals 36, and I'm going to divide by 9. So I got x squared equals 4. Now we're going to go through and square root each side, and x is going to be equal to, don't forget you square root to solve, you square root x squared and square root 4. Don't forget your plus or minus, folks. because 2 squared could equal 4, and negative 2 squared would also equal 4. So your two answers are plus or minus 2. Okay. Now looking over here, same type of issue here. I'm going to move over my 25, so I got x plus 13 quantity squared equals 25. Now the whole thing's squared, so I got to get rid of that square root. I'm going to get x plus 13 equals plus or minus 5. Subtract my 13, so negative 13 plus or minus 5. So negative 13 plus 5 is negative 8. Negative 13 minus 5 is negative 18. And there you go, are your two answers. So moving on, we're going to talk about solving quadratic equations by completing the square. So sometimes quadratic equations cannot be factored. Okay, so we have to try another method. Okay, and that method is completing the square. Now here's some guidelines for you, but I'm going to make it real easy for you. Okay, completing the square is usually going to be easiest when the leading coefficient is 1 and your b term is even. Okay, if you don't have a leading coefficient of 1 and a b term that's even, or you can't factor and make it that way, then completing the square is probably not going to be the easiest method for you. Okay, so let's go ahead and play with it. Okay, so looking at this first example, example number 9, we see that, the leading coefficient is 1 and the b term is negative 6. It's even. Okay, so what we can do is we can complete the square. Now, completing the square is a glorified way of saying I'm just going to add 0 and do it in a clever way such that I can factor it. Okay, so we're going to go x squared minus 6x plus something minus something, and then you have your plus 2 equals 0. Okay, and that thing that we're going to add and subtract, we're going to add and subtract the same thing. In math, you're always allowed to add 0 whenever you want. We're just going to do it in a clever way. Okay, so the thing we're going to put in there, I'll write it out for you, is completing the square. The little formula that we need to know is b, that's negative 6, divided by 2 quantity squared. So negative 6 divided by 2 quantity squared. And you can probably do that mental math in your head. You probably know that that's going to be x squared minus 6x. Negative 6 divided by 2 is negative 3. Squared is 9. So we're going to add 9 and subtract 9 to our original quadratic. Now, if you look, the first 3 terms that you're going to end up with are going to be easily factorable. Okay? X minus 3 times x minus 3. And here you have a minus 7 equals 0. So you end up with x minus 3 quantity squared minus 7 equals 0. Should look incredibly familiar to an example we just did about a minute ago, where we're going to use the square root property. Okay, so now we're just going to add 7 to each side, so we end up with x minus 3 quantity squared equals 7. And then we're going to get our square root on, so we get x minus 3 equals plus or minus radical 7. And then add your 3 over. 3 plus or minus radical 7. So 3 plus radical 7 and 3 minus radical 7 are your two answers to your quadratic. Pretty cool. Okay, looking at the next one, now I know the leading coefficient is not 1. Okay, and that doesn't really scare me all the way away, but it makes me a little bit nervous. Okay, I would have to factor a 3 off, or I'd have to divide everything by 3. If I divide my b term by 3, I'm not going to get an even number. And that's what I want. I want an even. I have an even number right now, but after I divide off this 3 to make my leading coefficient 1, I'm not going to have an even number. Therefore, I'm probably not going to complete the square. So you know what? I'm going to allow you guys to go ahead and skip this one. Go ahead and skip that one. And let's move on. Okay, so now we're going to jump down and we're going to talk about using the quadratic formula to solve quadratic equations. Okay, the quadratic formula will always work. So maybe you don't want to use completing the square like in this one up here that we were allowed to skip. Okay, maybe you don't want to factor it. Maybe you're not good at factoring it. Maybe you don't want to use the square root property. You can always use the quadratic formula if it's a quadratic equation to solve it. Okay, and there's the equation there, right there, negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, hopefully it'll catch you a little song and help you remember it. But it can be used to solve any equation belonging to the quadratic family. And that's important because we're going to start exploring higher degree quadratic family equations later in the year. Okay, so the first one we're going to do is this one right here. Let's put it in standard form. So it's x squared plus 3x minus 9 is equal to 0. And here our a is 1, our b is 3, and our c is negative 9. So when you go to use the quadratic formula, x equals negative b plus or minus the square root of b squared, which would be 9, minus 4ac, all divided by 2a. So that's going to be negative 3 plus or minus the square root. That's going to be 9 plus 36, which is 45, all divided by 2. Okay, you probably know that 45 is just 9 times 5. So radical 45 is going to be 3 radical 5. We can go ahead and change that. So negative 3 plus or minus 3 radical 5 divided by 2 is your final answer. Okay, so let's talk a little bit more about the quadratic formula here. So we're going to talk about one little piece of it called the discriminant. The b squared minus 4ac part is called the discriminant. Okay, it's got a name. And it's used to determine the nature, whether real or complex, and the number of solutions. So it's going to tell you if your solutions are real or complex, and it's going to tell you how many of them there are. So if b squared minus 4ac is equal to 0, then there's only one real root. Okay, because in the quadratic equation, the square root of 0 is still 0. So you're in with a b over 2a. Okay, a negative b over 2a, sorry. If b squared minus 4ac is bigger than 0, meaning it's positive, the equation is going to have two real roots because you're going to have that plus radical whatever minus radical whatever. And it's going to give you two real roots. And then lastly, if the b squared minus 4ac is negative, then the equation has two complex roots. Okay, two complex roots because you're going to have a negative number underneath the radical, which means you're going to have an imaginary I in there. Okay, so let's use the discriminant to determine if the equation has any given has any real roots. Okay, so we look at b squared minus 4ac. So that'd be negative 1 squared minus 4 times 2 times negative 1. So 1 plus 8 is equal to 9. So there is two real roots because there's going to be a 9 underneath our radical. Our b squared minus 4ac is equal to 9. Okay, let's take a look at the next example. So b squared minus 4ac. So we got negative 5 squared minus 4 times 2 times 5. And what is this? 25 minus 40, which is negative 15. You're going to have a negative number underneath your radical. So there's two complex roots. All right. Now jumping forward, let's talk a little bit about complex roots, complex solutions. The complex solutions of a quadratic equation with real coefficients occur in what we call conjugate pairs. Where you have one, you're going to have another. Where you have I, you're going to have negative I. Where you have 7i, you're going to have negative 7i. Always true together. And let's go ahead and prove it right now using the quadratic formula. Okay, so clearly we don't want to use completing the square. I don't know if I want to waste my time trying to factor this, finding factors of 15, then add to negative 2, and then trying to do grouping, which maybe we could, doesn't matter. Okay, so either way, let's use the quadratic formula. So my A is 3, my B is negative 2, and my C is 5. Okay, so x equals negative B, that'd be positive 2, plus or minus square root of B squared, so negative 2 squared, minus 4AC, all divided by 2A. So essentially we're going to get 2 plus or minus the square root of 4 minus 60, so negative 56, all over 6. Okay, Okay, if you go over and take a look at negative 56, we can go into the margin really fast and say, okay, negative 56, that's going to give us an I and a radical 56. Then that's going to give me an 8 and a 7. 7 has prime factors. That's 4 and 2. The 2 is going to get to come out, and I'm going to get stuck with a 14 inside. Okay, so this is going to become 2 plus or minus 2I radical 14 over 6, which is divisible. Everything is divisible by 2, so let's go ahead and just fix that to become 1 plus or minus I radical 14 over 3. And you can see right now, okay, that complex conjugate solutions come in pairs, okay? So 1 plus I radical 14 over 3 is an answer, and 1 minus I radical 14 over 3 is an answer. There's your two answers right there, okay? Every quadratic equation is going to have two answers. We'll talk a little bit more in depth about that because sometimes they're repeated. But either way, there's why you get two complex answers and why they come in conjugate pairs. 1 plus I radical 14 over 3 and 1 minus I radical 14 over 3 are conjugate pairs. Okay, so just a quick summary of how to solve for quadratics here. That's what this last box is. So if b is equal to 0, you have no b there, you want to isolate the x and use the square root property. This box is going to help you as you do your homework and you're trying to figure out how to solve which equations. If c is equal to 0, you want to factor out the x, or actually, I'm sorry, factor out the GCF, not just the x. We saw it earlier at 4.3x. Okay, factor out the GCF and solve using the zero product property. And if no coefficient is 0, then you want to try to solve by factoring the polynomial. You want to try completing the square, or possibly, last resort, using the quadratic formula, which will always work. You can jump straight to using the quadratic formula if you want. The other methods are just easier and faster if you can see when to use them. Okay, so this box will help you as we're solving any quadratic moving forward in our homework and all those things that we're going to be doing in class. So bring your questions to class, and I look forward to seeing you guys.